Alright, we're going to look at the algebra we use to solve equations with radicals in them. And of course, for starters, we're going to graph the left and right hand sides of the equation. Usually we do this by hand so we can learn how to do that. We use technology because this video is going to focus on the algebra. Now, the one thing that troubles me about the equation is that radical and square root, and I want to make it go away. So as we've learned before, we can undo things by applying the inverse operation of both sides. The inverse operation of square root is square. So I square the left and the right hand side. Now here's a nice little reminder. When you square a binomial like x minus 6, it's really x minus 6 times x minus 6, which reminds you need to FOIL. And so squaring the left hand side should give you x squared minus 12x plus 36. Now this is a quadratic equation. It's in quadratic form, and right now the only way we know how to solve quadratic equations is by using the factoring method and the zero product rule. So I need to have 0 in order to use the zero product rule, so I'm going to get rid of this x by applying the inverse of add x, which is subtract x, giving me a new quadratic equation in solvable form. So now all I have to do is factor. Since the coefficient on x squared is 1, I'm going to factor using the modified x box principle. Numbers that multiply to give me 36 that add up to negative 13 are negative 9 and negative 4. And those then will turn out to be the values inside each factor. Zero product rule says either this has to equal 0, in other words 4 minus 4, x equals 4, will make 0, or x equals 9, because then we'll have 9 minus 9 is 0 times negative times 5 is 0. So this is how we show the work. But I'm looking at my graph, I can see x equals 9 is clearly going to be the value of the solution. My algebra is telling me x equals 4. And so first of all, we need to cross this out because this is obviously not one of the solutions to my given equation. But we also need to understand why the algebra is telling us this lie. If we examine this graph a little closely and found out where x equals 4, that intersects the graph right here. And if I were to draw a square root function that was flipped like this is the opposite of the square root of x, gives me that green curve. That intersects the red line at exactly this spot right here. Looking at the equation, I was looking at the intersection of negative square root of x and x minus 6. So once again, I'm going to square both sides, but here's the money. When I square negative 1, it's going to give me positive. And when I square x, square root of x, I get x. This is an identical equation to the one we had over here. The difference is we keep x equals 4 and we get rid of x equals 9 because the green equation is solving for the flipped graph, where the red one is solving for the original square root graph. Notice here our solution x equals 9 is verified quite simply. It's almost one where you could use common sense and reason to find the solution. That would be easier than graphing or algebra. But since we're here to learn algebra, this is the approach that we're trying to master at this point. Thank you.